All right, everyone. So it is 3 o'clock, so I guess we might as well begin our USACO Bronze class now. So welcome everyone to the third week of the USACO Bronze class for Kid Teach Kid. And today we will be covering simulation and brute force problems in the USACO Bronze competition. Now, today is actually a special day for July 4th. So hopefully, so far, your July 4th has been going well. I'm not sure if any of you guys have plans to do something later on in the day, like, for example, go looking at fireworks or playing cards with your family. That's usually what my family and I tend to do. But yeah, hopefully it has been at least a pretty good holiday so far. As always, I have already posted this handout that I am looking at right now in the Google Classroom. And if you want, you can go to the Google Classroom, find this handout, and follow along by yourself, or you can also look at the screen, as I will be screen sharing this handout for the rest of the class. And since this always seems to pop up, I will quickly publish the Google Classroom link to everyone real quick, just because that also seems to fit. Just because in case someone has not yet joined the Google Classroom. But here's the link to the Google Classroom if you have not joined it already, where you can find all the past handouts. And another way to find all the past handouts is to go to the Kid Teach Kid website, but yeah. All right, and I think that's all the introduction that I have for today. So without further ado, let's get started with the content. Okay. So the first thing we're going to talk about is what simulation and brute force are. So I'm assuming that you've at least heard of what a simulation is before, and probably in the context of hey, are we living in a simulation today? And basically what a simulation means is everything not instead of everything being real life, is it really just instead a piece of code? And that's essentially what using simulation in USACO Bronze is. They give us, inside of the problem statement, they'll generally give us some sort of scenario, and then we simulate exactly what they tell us to. So for example, if they tell us to check every diamond, or if they tell us to check every number to see if it's divisible by 2, then simulating the problem, we might just directly check every problem to see if it's divisible by 2. And this will be just a direct simulation where we essentially just do exactly as they say in the problem statement. Now you might be wondering, well, wait, doing exactly what they ask in the problem statement sounds like every problem. And yes, that's technically correct, but simulation generally refers to where we do it without much optimization. So for example, an USACO problem might tell us to find the largest number inside of a set, right? And if we wanted to simulate the problem, maybe we could go through every single number and check if it's the largest number. But if we wanted to do a technique that might not include simulation, might be thought of as, for example, using binary search, where I'm not sure if you guys have played this game before, but where you do where they tell you to pick a number between 1 and 100. And once you pick your number, they tell you that they can guess your number in 7 guesses if you tell them if the number they're guessing is higher or lower. And the strategy to always optimize your guessing is always to guess in the middle, you guess 50, then they tell you if it's higher or lower, and then let's say that it's higher, then you can guess 75 and then 87. And essentially you can always half the number of numbers that you have left to guess. And doing something like this wouldn't really be considered simulation because you're not directly checking every individual number. And yeah. And I'd like to say that brute force is also pretty similar to simulation, or at least in the USACO Bronze level, they tend to go hand in hand. So using brute force on a problem is also exactly as it sounds like. It's essentially doing the most obvious possible thing, or just trying to brute force your way through the problem. And if you're wondering where the brute force analogy comes from, you can say that, let's say that my friend David is trying to get past a wall. So the most obvious or brute force solution would be to punch through the wall because, why wouldn't you attack a wall? And although this might sometimes work if the wall is made up of sufficiently weak material like paper, if the wall is made of bricks, then you're probably going to have to try something else. So yeah, that's essentially what brute force is, where you try the most obvious thing and hope that it works. However, if you're still not, I know that it isn't exactly, if you haven't heard of simulation or brute force before in USACO, then these explanations might not be the easiest to understand, but don't worry too much because I think that understanding these two concepts is easiest whenever we're like sort of looking at a practice problem, which we will do shortly in the future. So again, if you don't understand these concepts, then don't worry, because it's probably easiest to understand them by example. Yeah. And before we move on to the practice problems, I also want to make a few notes about simulation and brute force. And while simulation and brute force solutions are generally the easiest to think of, because we normally just take whatever's in the problem statement and directly apply it, it's also, because they're so easy to think of, it's also common for them to get time limit exceeded. Because, I mean, if brute force worked for every USACO problem, then there wouldn't be much thinking involved in these contests, which is not necessarily a good thing. So yeah, it's pretty common for them to exceed the time limit. So you might be thinking like, when should I use brute force? And however, I'd like to say that because brute force solutions are pretty easy to think of, if you have enough time left in the competition, then you can always just try implementing it, because implementing the brute force solution probably won't take too long. And I mean, implementing it might give you some good insight into the problem, even if it doesn't work. You might find a way to optimize your brute force solution to get a faster solution. And sometimes if you're lucky, the brute force solution might even like just directly work. So that's why I think it's, especially in the USACO Bronze level, it's generally worth it to like just try implementing the brute force solution. Now this isn't necessarily true at like higher levels for like silver, gold, or platinum, but even in higher levels, it can sometimes be helpful. And another thing you might be wondering is, okay, great, but like once I get into higher levels, how do I know for sure if a brute force solution will work or not? And the way that we tend to do this is by looking at the number of operations that our code will run. And before I start talking about the number of operations, I will say that it is definitely not necessary to understand like how operations work, like the number of operations and stuff, in order to pass USACO Bronze to get to USACO Silver. Like I remember when I was still working on USACO Bronze, I believe a year or two ago, I definitely did not understand the concept of how many operations I was running. So whenever I was coding, I would literally just try the first thing that came into my mind and hoped it worked. And if it didn't work, then I'll just try something else. So I never really considered like, oh, well, like before I started coding, I never really considered, oh, well, maybe this will run out of the time limit. I just tried to do like the thing I thought would work. So again, it's not like completely necessary to understand this. But if you want to understand this, then I've included a short, I will also go over like, I'll also include a short explanation for each problem, like about the number of operations, detailing why we know the brute force will work. So the rule is generally that if our code runs in under 10 to the 8 operations, then our code will generally be fast enough. So yeah, if you don't understand this part, then don't worry. Don't worry too much. Although, yeah, I will try my best to explain it below. So before we continue into the problems, does anyone have any questions about either what a simulation is or what brute force is, or like just any questions in general about the topic that we will be covering today? There's a question that asks, this may be personal, but have you made USACO Plat? Yes, I did make USACO Platinum very recently, so that was fortunate for me. Okay, and since there do not appear to be any more questions, we might as well move on to the first problem. So the first problem that we will be covering is will be daisy chain. And the link to the problem statement can be found here. And if you're unable to click the link, then you can go to the Google Classroom link I sent above, click on the handout that has been sent, and then click on the link yourself to get to the problem. And since since I think it's good for everyone to have a bit of time to understand the problem, I'll give you guys about 5 minutes to read the problem statement, think about possible ways to that you might approach the problem, and yeah, just try the problem for yourself. And I always say this, but I have attached the solution with the motivation right here, but I encourage you not to read this yet, and instead to just sort of think about the problem by yourself first before you're shown the solution, because I think this is the best way to sort of learn how to code in Java and how to approach USACO problems in general. So I will see you guys at about 3:15. Okay, it's 3:15. So hopefully everyone has had enough time to read the problem and at least think a bit. about how to do it. So now let's get on with how we might be able to think of a solution to this USACO problem. So the first thing that I always like to do when looking at these problems is to do the sample case out and make sure that I get the same answer as the sample case and understand what I'm doing. Because there have been way too many times in the past where I read the problem and I'm like, oh, okay, I know what the problem is, and I don't do the sample case. Then I like type up my entire code, realize it doesn't give the right answer on the sample case, and then I realize, oh shoot, I misread the problem, and I just wasted 2 hours coding a solution to the wrong problem. So that's why I think it's important to at least do the sample case, just to make sure that your understanding is not like completely incorrect. So let's do that now. Oh, what? Okay. So in the sample case, we are told we're given the input for 1, 2, 2, 3, 3. So what does this mean? Well, the first number here, 4, just tells us this just represents the number of flowers that we will have. So it tells us that we're going to have 4 flowers here. And as you can see, these 4 numbers represent the number of petals that each of the flowers will have. So the first number represents that the first flower has 1 petal, the second has 2 petals, the third has 3 petals, and the last one has 3 petals as well. So now, what do we have to do to solve the problem? Well, the problem, in essence, the problem statement is telling us that if we choose 2 numbers, I and j. Oh, was it 1, 1, 2, 3? Am I? Oh, thank you. I cannot read. Let me change that real quick. 1, 1, 2, 3. There we go. So in essence, the problem statement is telling us that we choose 2 flowers that can be the same flower. So for example, let's say we choose this flower and this flower. And then once we have chosen these flowers, actually, maybe it's easier to understand if we choose these 2. So let's say we choose this flower and this flower, for example. Now, we calculate the average of all flowers in between the 2 flowers that we chose. So since we chose 1 and 3 here, the number of flowers in between would be 1, 2, and 3. After we've done this, we calculate the average number of petals that these flowers have. So in this case, it would be 1 plus 2 plus 3 divided by 3, which is 2. So the average number of petals in this set of flowers is 2. And finally, we go through the flowers and check if any of them have the average number of petals. And obviously, we can see that this flower has the average number of petals. So how do we do this? So let's see how we might get the answer of 6 for the sample case. Let's start by choosing 1 as the left-hand side. So like let's say this is our leftmost boundary, and then we'll do cases on what the right boundary is. So let's say that the leftmost boundary is 1. Note that we can choose the same flower as both the left and the rightmost boundary. So the first case is where we choose 1 as the left boundary and 1 again as the right boundary. In this case, the average number of flowers is 1 because it's literally just 1 over 1. And obviously, there exists a flower with the average number of petals, 1. So we now have a count of 1 as our answer. Let's say that this is our answer. We have a count of 1. All right. Let's move on to the next case where we choose this left one. This one is the leftmost boundary. This one is the rightmost boundary. So when we choose these 2 flowers, again, the average number of flowers is 1, and the average number of flowers is 1. And obviously, there exists a flower in this set that has 1 flower. So let's add another tally to our answer. In the next case, where we choose 2 as our rightmost boundary, the average number of flowers is 1 plus 1 plus 2 over 3, which is an integer, which is not an integer. It is like 1.3 repeating. So obviously, in this set of flowers, we're not going to have a flower with a decimal number of petals, so we do not add a tally for this case. And finally, the last case here is where we choose 3 as the rightmost side. And when we add these up, we can see that there's 1 plus 2 plus 3 over 4, average number of petals. And again, this is 7.4. This is equal to 7 over 4, which is not an integer. So we do not add a tally for this case because the flowers must have an integer number of petals. All right, great. And we can do similarly for the other cases. And since there's not that many, we might as well do them all out. So let's say now that we choose this one as our leftmost boundary. The two cases that we have to consider are choosing, okay, so yeah, we might as well just get started with choosing the cases. Wait. Okay, so the first case is choosing this as our rightmost boundary. When we do this, the average number of flowers is 1, and obviously there exists a flower, so we can add a tally here. Oh, whoops. The next case is where we choose this flower as our rightmost boundary. The average number of flowers is 1 plus 2 over 2, which is not an integer, so we do not add a tally for this case. And the next case is where we choose 3, and we can see that the number of flowers here, the average number of flowers in the set is 1 plus 2 plus 3 over 3, which is equal to 2. And when we check the flowers in this set, we can see that there does exist a flower with 2 petals, so we add a 4th tally. And that finishes this set of cases. And let's move on to the last case, or like one of the last cases, which is where we choose this 2 as the leftmost boundary. Again, we can choose the 2 as the rightmost boundary as well, and this obviously works, so we can add another tally. And the other case is when we choose this 3 as the rightmost boundary, but the average number of flowers is again not an integer. 5 over 2 is not an integer, so we do not add a tally for this case. And the last case is when we just choose 3 as both the leftmost and the rightmost boundary. So obviously 3 over 1 is an integer, and there does exist a flower in this set with 3 petals, so our final answer is 6. And that's how like the sample case can be done in this problem. So now, how do we come up with a solution to this? Well, since this handout is called brute force, we might as well try the brute force solution, you know? And if we look at what the problem actually asks us, the problem asks us to look at every possible pair for a left and rightmost boundary. So it wants us to look, for example, at this pair. It wants us to look at this pair. It wants us to look at every single pair of every possible pair of a set of flowers. So why don't we try doing that? And then once we've done that, it wants us to calculate the average number of flowers. And then it wants us to check, after we've calculated the average number of flowers in the set, it wants us to find if there exists a flower with that many petals. So why don't we just try doing directly what the problem statement asks? Because that is what the brute force solution would entail. And it just so happens that this does actually run within the time limit, primarily because n, or the number of daisies, is so small. So let's look at how we might code this solution, because I think some people might find this some people might find this particularly helpful. All right. So as you can see, we are on daisychain.java. So let's see how we can start the problem. So the first part of the solution is going to be reading in the numbers. And as you can see, we are first given the number of petals, the number of flowers. So let's use the integer f for the number of flowers. So like int f equals kb equals the next integer. So f is the number of flowers. And this is true because we're just reading in the next integer, which is done here. The next thing that we're going to have to read in is the number of petals for each flower. So let's run a loop to do this as well. So we can do for int I equals 0, I less than f, I plus plus. Oh, and we also have to declare an array. So like, let's say that this array flowers, actually we can call this petals, because it represents the number of petals for each flower. So petals holds the number of petals for each flower. And then in this array, we can say let int numpet equals kb.nextInt. And then we just insert every single one into the array. So like this. So fill up the array petals with the input, with the given input. So does this make sense so far? What we've done so far is we've read in all of the input. So we've let f is the number of flowers, and what this part of the code here does is it fills up the array petals with the number of petals for each flower that the code gives us. Okay. see anyone asking any questions, so we will move on. And now the next part of the question is choosing a left and right boundary. Because as you can see in the solution we described, we want to check that for every left and right boundary, for example, like these two, we want to check that for every left and right boundary, if it is possible, if there exists a flower with an average number of petals inside that set. So let's do that with two loops. Let's say for int I equals 0, I less than f, I plus plus, and for int j equals I plus 1, j less than f, j plus plus. Now, if you're not sure what this does, what these two loops essentially choose an I and a j such that I and j are not equal. Oh, sorry, actually, they choose an I and a j such that I represents the left boundary, so we can say that this is the left boundary, and j represents the right boundary. And if you're wondering, well, why can't j ever be less than I? It's because when we start the inner for loop, j is declared as equal to I, and the variable j can only increase. So as a result, this covers all the possible cases for a left and rightmost boundary for when we're doing the code. All right. So now we have that these two loops will loop through every possible set of boundaries. But what do we do now? Well, the next step should probably be to find the average number of flowers. So let's say that int average equal, well, actually, since the average can be a fraction, we should declare it as the double. So let's say double average equals 0 for now. And in order to get the average, what we have to do is we have to first add up the number of petals for every flower in the set, and then divide by the total number of flowers. So let's start by adding up the total number of petals. So for every single flower in this set, so this means for all integers from I to j, like this, we can add the number of petals at this index to average, like this. So this loop ensures that average now equals the sum of the number of petals in the set between the left and the right boundaries. And the last step to make sure average is properly computed is to divide average by the total number of flowers. And since the left boundary is I and the right boundary is j, this is just equal to j minus I plus 1. All right, so now average will equal the average number of petals. So we now have the average number of petals. And the final step before we can solve the problem is checking if there actually exists a flower with this many number of petals in the set. And in order to do this, all we have to do is run one more for loop. So we loop through every single flower in the set and check if it has the correct number of petals. So again, for int k equals I, k less than equal to j, k plus plus, we check if the number of petals of this flower is equal to average. Then let's say that our answer is 0. Then we add 1 to the answer, and we're done, like this. And so what this does is it goes through every single flower inside of the set, checks if the flower is equal to the average number of petals, and if it is, then we add 1 to the answer because this set of flowers actually works. And in the end, to finish, all we have to do is system.out.println. We just have to print out the answer and check that it works. So now let's see if this is valid. And let's submit it to the USACO website and see how many test cases we get. So let me go to the USACO website. How do I get there? Wait. Shoot, where's the USACO website? Here it is. So we can come here, click Java, choose file. We can paste in our URL and submit the solution. And let's see if we get the test cases correct or not. Okay, and it looks like we did get all of the test cases correct for this problem. So yeah, that is the brute force approach for this problem. Someone asks in the chat, is plus equals the same as plus plus? Okay, so yeah, basically. So what plus plus does is it increments the variable by 1, what plus equals does is it increments the variable by whatever you tell it to. So for example, if I did like a plus plus, then a would increase by 1. If I did a plus equal 2, then a would increase by 2. That's the difference between the two. Does anyone else have any questions about how we were able to solve this problem? Someone asks, how did we take the input at the beginning of the question? So the way we did this, so I did cover, I briefly went over how to do input output in Java in the first handouts in the first class. So if you want to quickly review that, you can always go to the Google Classroom and go to the first handout where I have briefly gone over how to do this. But essentially what we did is, the first thing we did was we declared a scanner, as I've done here. Then after that, so what this part does right here is we declare an integer f, and we say that f is equal to the next integer in the input file. That's why it says .nextInt. So since USACO tells us that the first number will always be the number of flowers, then we know that f must be the number of flowers. Afterwards, we want to read the number of petals in each flower into an array. So the standard way to do this is to first declare an array to hold each input, as we've done here, and then afterwards we run a for loop to read the number of petals into the array. So since it's given that the number of flowers that will appear here is equal to the first number that is given, so in other words, there will be f inputs here. We can run a for loop from 1 to f, as shown here. We then in each iteration of the loop, we read in the number, and then we give the number into the according position of the array, which is shown. I hope that makes sense. Wait. Also, wait. Can you guys hear the loud fan that is going on in the background? I do not know, because it appears that my mic is like going green. Oh shoot. Hang on. Let me see if I can change that real quick. That is not good. Okay. Can you guys hear it now? Okay. Only when I talk. Well, I guess that will have to do, because I do not know if there is another way to stop it when I talk. Okay. But yeah, my apologies. All right. So I guess since no one else has any questions, oh, I see someone has a question in the Q&A, but I will answer that. I'll answer that when everyone else is reading the next question. But for now, I think that we can move on to the next question. And yeah, so moving on to the next question, which is triangles. The source of this problem is from the USACO 2020 February contest, problem 1 for the bronze level. And again, the link to the statement can be found here. But as usual, I'll also screen share the question in case you want to read it. So I'll give you about 5 minutes to read the question. So we will come back at around 3:39. So here's the question statement. And hopefully you guys can think a bit about how to solve the problem and just understand the problem in general, do the sample case yourself, that sort of stuff. So yeah, see you guys at 3:39. All right, it is 3:39. So hopefully that was enough time for you guys to all read the problem. And let's get started by, as usual, analyzing the sample case, and then we'll get on to how we might approach the solution. So yeah. In the sample case, we're given 9 numbers. The first number represents the number of coordinates that will be used in the problem. As you can see, there are 4 sets of coordinates here. And then after that, every number represents 1 set of coordinates. So the first point is 0, 0. The second point is 0, 1. The third point is 1, 0. And the last point is 1, 2. So let's look at how this might be done. All right. 0, 0. Okay, I just want to make sure that I have properly memorized the points, and I do not mess them up like I did last time, because that would be very sad. So let's start by drawing our grid. Okay, these might not be equal spaced, but they're probably good enough. I think that's enough points for our grid. So now let's plot the points that we're given. So the points we are given are 0, 0, 0, 1, 1, 0, and I believe 1, 2. So right here. All right. So now the problem asks us to find the 3 points that form a triangle of maximum area, with the additional condition that the triangle that is formed must be a right triangle with one of its sides parallel to the x-axis and one of its sides parallel to the y-axis. So what this means is that while a triangle like this one might work, a triangle like this one will not. So for example, this triangle is invalid because it is not a right triangle and it does not have one of its sides parallel to the y-axis. And in addition, a triangle like this, where this angle is right, is not valid because it does not have one side parallel to the x-axis and it does not have one side parallel to the y-axis. So yeah. Now let's look at which triangle here has the maximum area. We can see that this triangle right here is valid because it is a right triangle. This side is parallel to the y and this one's parallel to the x. So this is a valid triangle. And if we calculate the area of this triangle, we can see that base times height, this is 2 times 1. So the overall area is 1. But actually, since the question is asking us for 2 times the maximum area of a valid triangle, instead of dividing by 2, as one generally does when doing base times height over 2 for the area of a triangle, we will just leave the area as 2 without dividing by 2. So whenever we talk about area in this problem, we're going to assume that we're talking about double the area because that's what the problem is asking us for. So now let's say that, okay, so this triangle has an area of 2. So now what other triangles exist in this? What other triangles in this diagram fit the possible criterion for a problem? Well, another one is this one, but this one only has an area of 1, which is definitely smaller than 2. So 2 is still the biggest one. And if we try any other combination of 3 points, we can see that no other ones fit our criterion for a valid triangle. So as a result, our answer just ends up being 2. And if we look at the sample case, oh, not this question. If we look at the sample case, wait, why can I not X out of this time? If we look at the sample case or the sample output, we can see that the answer is indeed 2. So yeah. Now, how are we going to, now that we have a decent understanding of how this problem works, how are we going to approach this problem? Well, again, since this is the brute force handout, let's think about a brute force way to do the problem. So we want to find the maximum area of a valid triangle, right? And a triangle is formed by 3 points. So, I mean, why don't we just try looking at every single possible combination of 3 points and then finding which triangle has the maximum area? Because that sounds like a pretty good idea. And it turns out that this is actually the way to do it, with a few extra conditions, of course. So how specifically, how are we going to do this? Well, the first step is we're going to run a few loops and loop over every single possible set of 3 points in the diagram that we are given. The next thing we will do is check that the set of 3 points that we use form a valid triangle. Or in other words, one of its sides is parallel to the x-axis and one of its sides is parallel to the y-axis. And then once we've done that, if the set of 3 points we have chosen fits that criteria, then we will check if it is larger than the current maximum and store the maximum over all triangles in a variable. And to conclude, we will just print out the variable, which will be our answer. So yeah, let's look at how we might code this in Java. All right. This is our successful code for triangles. Oh, this is our successful code for daisy chains. So we can X out of here and then go on to triangle. So this is our template for triangle problem. And you might notice that this looks a bit different. I'll open up daisy chain again. But if you can see at the top of our daisy chain code, we only have scanner kb equals new scanner with system.in. But in triangle, we can see that we have like new file triangles.in. And we also have this extra line like print writer out equals this weird thing and then out.close. And the reason we have to include this for this specific problem is because this USACO 2020 February contest bronze is from before, this is before the 2020 December contest. So as a result, they still use input output from files, which is why we have to include these extra lines. However, if you participate in recent USACO contests, like the upcoming one, I believe the next one is in December. So if you participate in any future USACO contests, you will not have to deal with input output from files because that is not a thing that is required anymore. Instead, we can just use system.in and system.out. So now let's go back here and let's get started. So as usual, we will start by inputting all of the variables. So the first variable is just equal to the number of triangles. So let's say that, let's say int numTry, this just represents the number of triangles, is equal to kb.nextInt, as usual. So we can say numTry reads in the next integer, the first integer is the number of triangles. All right, great. So now we've read in the first number, and we also have to read in the next set of points. So we can use a similar strategy to what we did above to read in these points by using a for loop and storing all of the points in an array. So the first thing we're going to do is create an array to store these points. However, we might notice that in each point, unlike the previous problem, each point actually needs 2 numbers stored this time instead of 1. So as a result, we can use this cool thing called a 2D array to store 2 numbers for every single point. And the way this is declared is as follows. So we can say coordinates. Actually, let's just say chords for short. So what this does here is it declares a new array with number of triangles as the number of rows, except now we can store 2 numbers in every index instead of just 1. And the way we would use a for loop for this is as follows, like this. So once again, we loop through the total number of coordinates that will be read in, like this. And then, since for every index we're reading in 2 numbers, we declare int x equals, so x will be the first integer that is read in, or the x coordinate. Y will be the next integer that's read in, or the y coordinate. And then finally, we just store them in the array. Done like this. Oh, whoops. All right. And this piece of code will allow us now to have numTry as the number of triangles, and chords will store the coordinates for every set of points. All right, so we've now successfully read in all of our input, but now we have to do now we actually have to implement the problem. So how are we going to do this? Well, let's start by looping through every set of 3 points, as we discussed above. This is the first step. So again, we can create, since we're looping through 3 points this time, and we want every set of 3 points, we can create 3 arrays. We can create 3 for loops with each for loop representing one of the points. So let's call them A, B, and C, for instance. So, whoops, forgot to say integer here. So each of these three for loops represents one of the points. And if you're wondering why we do int b equals a plus 1 and int c equals b plus 1 here instead of like int b equals 0, the reason we do this is because it's like sort of a handy trick, because when we declare it this way, now none of the points will ever be equal. So for example, inside of this for loop, we will never have to deal with the case where a is equal to b, or b is equal to c, or a is equal to c. So this is like sort of a helpful thing you can do with your for loops if you don't want duplicates. All right, so now we have a, b, and c will take on every single set of 3 points. The next thing we need to do is check if this set of 3 points, we need to check if this set of 3 points satisfies the triangle conditions. Or in other words, 2 of the x coordinates are equal, or 2 of the y coordinates are equal. Sorry, we need to have one of the sides parallel to the x-axis, and this is equivalent to having 2 of their y coordinates equal, and we also must have one side parallel to the x-axis. And this is equivalent to having 2 of the points is x coordinates equal. So now we're going to write a pretty big if statement to do this. So let's say that, so one thing to notice is that in a right triangle with one of the sides parallel to the x-axis and one parallel to the y-axis, like this, you always have a point that is like at the right angles, right here. So if we look at this special point right here, we can see that this is the point that has the same x coordinate as this point and has the same y coordinate as this point. So one of the points will have both one same x coordinate and one same y coordinate. So let's do cases on the possible things we can do for this. So the first case is that the point A is the corner point, or that the point A has both its x coordinate and y coordinate equal to the x and y coordinates of 1 and b and c. So this means that either we have chords. We either have the, by the way, chords A0 represents the x coordinate of point A, and chords A1 represents the y coordinate of point A. So yeah, so we must either have the x coordinate of point A equal to the x coordinate of point B, as well as the x coordinate of point, the y coordinate of point A equal to the y coordinate of point C, like this. Or we must have the reverse, which is, give me 1 second. Or we must have the reverse. Oh shoot, why is this formatting weird? The reverse, which is the x coordinate of point A is equal to the x coordinate of point C, and the y coordinate of point A is equal to the y coordinate of point B. So these are the 2 cases for when A is this central point, sort of. But the thing is that this is not the only case, because this point can also be B, and it can also be C. So now our if statement will also have to incorporate the cases for when B and C are that point. So we're going to have to do a fair amount of copy pasting. So to have this condition match up, let's say, so we can do this, have in all of our ors. And now from here, we just shift all of the variables by 1 like this. Okay, this should work. And then this goes here, and this goes here. And if you're wondering what this really long if statement does, it essentially just checks if this long if statement just checks if there exist 2 points out of the set of 3 points that we've chosen, such that 2 of them have equal x coordinates and 2 of them have equal y coordinates. And the reason it's so long is because there's multiple cases we have to check, because we don't know which 2 x coordinates are equal and we don't know which 2 y coordinates are equal. So we have to check for all of the possible cases, which is what we're doing here. All right, great. And now if our triangle has 2 equal x coordinates and 2 equal y coordinates, then let's say that the maximum area is represented by this variable. Let's say max area. Yeah. So the next thing we're going to have to do is to find the area of this triangle. Luckily, there is a very and one interesting note is that we actually do know the x and y coordinates for all of the points in this set. So as a result, we can use a very helpful formula called the Shoelace Formula. I'm not sure if you guys have heard the Shoelace Formula, but I will briefly go over it real quick. So the way it works is let's say that we have let's say that we have 3 points inside of the coordinate plane. So let's say that one of the points is represented by like the point 2, 3. One of the points is like 4, 5, and the last point is 1, 0. So there's actually a nice way to find this area. And if you're wondering, well, how on earth am I supposed to find this area? Because these are coordinates, right? And it can be hard to like identify the area of a triangle on the coordinate plane. So what we do is we write the numbers like this. So let's say that, so the first one we write is 1, 0. So we can imagine it like 1, 0. The next point is 2, 3. The last point is 4, 5. And to finish off, we write whatever the first coordinate we wrote was, we write it again at the bottom. So since the first one we wrote was 1, 0, we write it again. So now we have this listing of all of our coordinates. And if we do the following trick, where we multiply these two, multiply these two, multiply these two, and then multiply these two numbers, and these two numbers. So let's start by multiplying 1 and 3. When we multiply these two, we get 3. When we multiply 2 and 5, we get 10. And when we multiply 4 and 0, we get 0. Now let's do the same for the other side. When we multiply 0 and 2, we get 0. Multiply 3 and 4, we get 12. And when we multiply 5 and 1, we get 5. So the reason this is called the shoelace formula is because this actually looks like a shoelace pattern, which is pretty cool. Once we've done this, if we add up the numbers on each side, so this is 17 here and 13 here, then if we subtract the two numbers, which is 4, take the absolute value and divide by 2, then we actually get the area that is formed by these points. So in this case, it would be 2. Nice. So this formula will actually this formula is actually really useful inside of this problem. And the reason for this is because we can now find the area of the figure of the triangle formed by the points. And by the way, if you're not entirely sure how you would do this inside of code, but you understand this example, then the way you would do it is like you would replace 1 and 0 with like A1 and A2, and then B1 and B2. And then you would just do like this product is A1 times B2, and you would like have a lot of variables, and it's kind of messy. But to save you some time of having to do all the variables out yourself, I would just type it out here. So we can actually calculate the area. So let's say that int triangle area. We can actually use the following formula, which is like this. It's equal to the x coordinate of point A times the y coordinate of point B plus the x coordinate of point B times the y coordinate of point C plus the x coordinate of point C times the y coordinate of point A. Like this, I believe. All right. And then once we've done this, we must actually let me put parentheses here. Once we've done this, we must also subtract off the area of the y coordinate of point A multiplied by the x coordinate of point B plus the y coordinate of point B multiplied by the x coordinate of point C. And then lastly, plus the y coordinate of point C times the x coordinate of point A. So it's a long formula, and it can be a bit tricky to derive, but it's not too hard if you like just plug in A, B, C, D into this and like do it out yourself. So once we've done this, the final step is to say max area equals math.max triangle area and the old maximum area. And what this does here is it sets max area to the maximum of the new triangle area and the old area. So max area will always be whatever the largest area is. And now that we finished, the last step is to just print out our answer. And in this case, we can just do out.println max area like this. So now let's see if this works. I will again take the properties. Right, let's go to the USACO uploading site. Switch language to Java. And check if this gives us the correct answer, which hopefully it does, because we are very out of time. If it does not, then that will be very sad. Okay, well, it gave us the answer to the first one. Oh, shoot, did I? Okay, wait, let me quickly check. If I'm not able to find it in about one. Oh, are my if cases wrong? Oh. Oh, I see. Okay. This is supposed to be B. My bad. Okay. And this is supposed to be C. This is supposed to be A. I am very good. Okay, I believe this works now. Okay, Andy, sorry for taking up your time, but I will just check one more time. And if this does not work, then yeah, I guess that is unfortunate. Okay, I think it worked for all of them this time. So yeah, that was the last problem for triangles. And I believe someone had a question about asking where the shoelace formula came from. I don't actually know, but I think it's still pretty funny that they call it the shoelace formula. And yeah, since time is basically up, I'll just say one more time that if you want to practice brute force problems, then I have 5 practice problems written here, and you can do them on your own time for homework. All of them are brute force problems, and I believe they'll be pretty instructional. So yeah, my time is up. It is now Andy's turn to be the host, and hopefully, if you guys are interested, you will all stay for his really cool USACO silver coding class. So thanks so much to everyone for coming, and I will see you guys later.